Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Stick to Triangle. It's a medium problem, so you guys can go over it once. So just to explain the problem real quick, assume we've been given a stick of length 1. Actually, you can take whatever you like for the length, but I've just taken it 1 to simplify the problem. And we choose two random points, let's say P1 and P2, between the values 0 and 1, which are basically denoting the points where we break the stick. And what we end up is with three lengths, as you can see in the picture over here. And what we've been asked is that what is the probability that we could form a triangle, right? So this is basically a problem where the trick is to try to understand what exactly is the question asking. Once you convert it into a mathematical problem, it's pretty easy in my opinion. So the trick is in understanding that we can look at P1 and P2 as two continuous random variables and since it's mentioned over here that choosing 2 points randomly along its length, boom, randomly, we should instantly understand that these are uniformly distributed continuous random variables. And we already know that whenever a problem mentions uniform distributed random variables, it's most likely is 99% of the time it's problem of graph shading. So yeah, so we've been given two random variables which are gonna vary between 0 and 1 and are uniformly distributed between these two values. Okay, so this is only half of the problem. The other half is understanding what exactly is the constraint given to us. We already know that, okay, so for the total sample space, it's basically going to be something like this. Basically, this unit square over here, right? This denotes the entire sample space because P1 can be any value between 0 and 1, and so could P2. So this entire square becomes our entire sample space. But what is asked of us? The probability that we could form a triangle given these three lengths that have been denoted over here. Now, first of all, what is usually the constraint when we're dealing with the possibility of three lengths forming a triangle? Well, it's that any two values, say L1 plus L2, has to be greater than L3. And I mean, you could have L2 and L3 over here, L1 and L3 over here, or L1 and L2 as given. But basically, the sum of any two lengths should be greater than the third, right? So now the question becomes, how do you convert this constraint on the length into a constraint on P1 and P2? Well, if you come to the graph over here and try to bisect this along the 1 by 2 lines and come back over here for a second. So you can see that L1 is basically the distance between 0 and the leftmost of the values between P1 and P2, right? And L3 similarly is the distance between 1 and the rightmost of the values between P1 and P2. Now, since L1 and L3, both have to, in any case, be less than L by 2, since each of these values, L1, L2, and L3, all of them can't be greater than or equal to L by 2. If that happens, if one of the three values is greater than or equal to L by 2, then it is impossible to satisfy this case, right? So, okay, so L1 and L3 both have to be less than L by 2. Now, this means that if I were to draw the 1 by 2 line over here, P1 and P2 both can't be towards the right of 1 by 2, and both together can be towards the left of 1 by 2. Well, on the graph over here, this means that this portion over here and this portion can't be possible, because for this part over here, L1 and L2 P1 and P2 are both greater than 1 by 2, and over here P1 and P2 are both less than 1 by 2. So we eliminate these two options, these two quadrants. Now, another thing you guys could notice is that the modulus of P1 minus P2 has to be less than 1 by 2. Otherwise, the value of L2, which is basically the modulus of P1 minus P2, would be greater than L by 2 or 1 by 2, whichever way you want to put it. I've had L as equal to 1 over here. But yeah, so the value of L2 is basically this value over here. And we also have the constraint similar to L1 and L3 on L2 also, that L2 has to be less than L by 2 or 1 by 2 in my case. So this is the third constraint that we needed. So plotting out P1 minus P2 modulus less than 1 by 2, we get these two portions over here. Basically this portion and this portion. And if you calculate the areas of these two portions and divide it by the entire area of the unit square, you get a value of 1 by 4, which is the answer to this problem. This is the probability that we can form a triangle from the three subparts of the stick that we get by choosing 2 points randomly along its length. I hope you guys understood the solution, and thanks for watching.